So in this video, I'm just going to show you a quick example of how you can use completing the square with integration. So here's the example that I'm going to show you. So I've got dx over the square root of 2x minus x squared. So, okay, this is just like an integration trick. And why would you ever think to use this? I would say, honestly, it's because you just don't have any other options. So for instance, if I try to set my u equal to 2x minus x squared, let's say I'm like, oh, I'll use substitution. So the thing is that when I take my du, like, this is not a great result because I have no like 2 minus 2x anywhere in this. So, okay, this isn't going to work. So the only other thing that really comes to mind then, let me clear some space, is that this looks like something that I would complete the square on. So if you completely forgot what that even means, I mean, just now chalk this up to like a, okay, I completely forgot this trick. Like, this is kind of how you learn things, and this is kind of what happens with integration. Okay, so what do I mean by completing the square? So with completing the square, so I strongly recommend that you write the squared term first, and let's factor out the negative. So I'm just going to rewrite the expression under the square root as you see here. Okay, so completing the square. So you always start with the number that is in front of the non-squared term. That is your b. So my b is -2, and then to complete the square, you take half of that. So half of b is -1, right? I just divide 2 by, or -2 by 2, and I get -1. And then I square that result. So -1 squared is equal to 1. Okay, so that's what completing the square is to start. And then, so just watch this now. So I'm going to bring this one, boop, right into here, okay? Now, I don't want to upset the apple cart in that I don't want to bring a new value into this. I want to keep the overall value of this expression the same. So remember, I have a negative here and a 1 here. So I've brought in a value of -1 to this expression. So to keep the equation in balance, I'm going to add +1 on the outside. So if I add this +1 on the outside, I have effectively added 0 to the equation, and that keeps everything in balance. Okay, so now that I've done that, now I can finish my completing the square. So I can write this right here as a perfect square binomial. So that's going to be x minus 1 squared plus 1. Okay, now if you forgot how do I factor this, you can always just reference this half b. Your half b is always what you're going to factor this as. So here's what I'm left with. So now I'm going to just I'm going to reorder this as 1 minus x minus 1 squared to make it look pretty. So that's what's going to go here. This 1 minus x minus 1 squared, that's where I'm going to put that. Okay, so let me clear some space. And now let me just rewrite this integral with our completing the square. Okay, so now I've restated this integral. Okay, now my friends, we need to talk about a huge abuse of algebra before I go any farther. So I want to just state this square root does not equal this, okay? So I am not allowed to break up a square root like this. I see this happen all the time. So the only way you can really simplify a square root is if you have something a times b, then you can break that up into the square root of a times the square root of b. That's the only real rule that you really have. When you're adding stuff like you see here, we cannot simplify this any farther. So it's not like we magically made this a ton simpler. We've just rewritten this in another way so that now we can think about how to deal with this. So let me clear some space. Okay, so at this point, now I would like to see if I can rewrite this again. So let's try substitution again. So now, what if I let my u equal x minus 1? And okay, then in that case, my du is going to be 1 dx. Okay, so let's see. What is that going to give me? Oops, so that's going to give me now du over the square root of 1 minus u squared. Okay, so now this I can actually work with. This integral just equals, this is the antiderivative for inverse sine. And so from here, then I can just plug in what my u is. So this is going to be inverse sine x minus 1 plus c. So sometimes with substitution, we just have to get a little bit more creative and use completing the square, and that can help us solve it. So if that was helpful, please consider giving this video a like. And I will catch you guys in another video.